Okay, let's have a look at this example. I think before we start, it's worthwhile just marking the radii, which is just there and there, so we know that they're of equal length. And we're told that the line AD is a tangent, so I'm going to pop that in so that it's obvious. And yet again with these questions, there's a missing chord here. AC is missing. It means we can see what's standing on that chord more easily. Okay, let's have a look. With a tangent, you can see that we've got a radius attached to that tangent, meeting at the same point A, and Rule 4, or Theorem 4, says that tangents and radii meet at a right angle. So we can pop this in here as a right angle. Well, we're home and dry, effectively, because the triangle OAD is a right angle triangle now. And the angle that they want us to find, which is this one up here, is part of that right angle triangle. So we can simply write down that 38 plus 90 plus our mystery angle, which we'll call x, is equal to 180 degrees. Therefore, x is equal to 52. So we can add that to the diagram. This angle up here is 52 degrees. Now they're asking us, work out the size of angle ABC. ABC, so it's this one up here. Well, now we popped in that chord AC, we can see that that chord subtends an angle to the centre of 52 degrees, and it also subtends an angle to the circumference. And they're in the same sector of the circle, so we're okay. Circle theorem 2 says angles to the centre of a chord and double those at the circumference. So this angle here that they need us to find is simply, let's call it y, is equal to 52 divided by 2, which is equal to 26 degrees. So this angle up here is 26 degrees. And that's it. But they ask us to give a reason for the answer, and you just need to quote the relevant circle theorem, which is this theorem up here, which is number 2.